Dear students, let's see this question. A projectile is fired from horizontal ground with speed v and a projection angle theta. When the acceleration due to gravity is g, the range of the projectile is d. What is given? A body is projected with some speed v and projection angle is theta. When the acceleration due to gravity is g, the range is given as d. And he is saying that if at the highest point in its trajectory the projectile enters a different region where the effective acceleration due to gravity is g dash, where g dash is equal to g upon 0.81, then the new range is d dash, which is equal to nd, the value of n. He is asking find the value of n, and this is JEE advanced question 2022. See what is given here. Is saying that a body is projected with some speed v by making angle theta. When the acceleration is g, acceleration due to gravity is g, is saying that the range of the projectile is d. The range of the projectile is d. And what he is saying, at the maximum height, for example, this one is the maximum height. At the maximum height, it enters into the new region where the acceleration due to gravity is g dash. Where the acceleration due to gravity is g dash. When acceleration changes, then automatically here the range will also change. That's why he is saying that when it enters into the new region, the range is given as d dash. The range is given as d dash, which is equal to nd. Which is equal to nd. He is asking that find n value. We can solve this one easily. See, he is saying that when a body is projecting with some speed v, just to resolve into components, along x-axis it is v cos theta, and along y-axis it is v sin theta. Along x-axis it is v cos theta, and along y-axis it is v sin theta. We know that when a body is projected, the horizontal component of velocity remains constant. Horizontal component of velocity remains constant, which means throughout the projectile motion, the horizontal component of velocity v cos theta remains same. And while it is moving to the maximum height, this y component velocity keeps on decreasing, and at the maximum height, y component velocity vy is equal to 0, and at this point the projectile is having only one velocity, that is v cos theta. That means we know that at the maximum height the body or the particle is having only one velocity along x-axis, that is v cos theta. Now from this point the region is changes. So just I am assuming that this particle is projected from the tower. Particle is projected from the tower of height h with velocity v cos theta along the x-axis. And in this region the gravity is g dash. Now I want to find out the range. Here in this case I am going to calculate the range here. And one thing we know that if the total range is given d, such that further half it will be d by 2. So this one we know it is d by 2. This one I will calculate. This one I will calculate. The total when it is entered into the new gravity, total is given as d dash is equal to nd. So I can compare, I will get the values. So now first we will write along x component and y components. While we are solving the projectile motion, if you are feeling it is difficult to solve, try to write down the x values and y values. So if you write x values and y values, then it will be easy to solve. So in this case, at this point we can write u x can be written as v cos theta. Ax will be 0. Ax will be 0. Here vy is equal to 0. Y is 0. The body is projecting along the y-axis. Sorry, the body is projecting along the x-axis. That's why y component velocity is 0. So ay is equal to plus g dash. Ay is equal to plus g dash. Now I want to calculate the range. So range formula range formula, range is equal to horizontal component velocity, which means here v cos theta into time of light, horizontal component velocity into time of flight. Now first we are going to calculate the value of t. I will write this is equation 1. Now I want to find out the time of flight. In order to find out the time of flight, I will consider the y components. So we know that along y axis I will apply s is equal to ut plus half et square, and s is nothing but the maximum height. Along y axis the velocity will be 0, the whole component becomes 0, plus half g dash is given, it is t square. I will write h is equal to half g dash t square. Now here h is the maximum height and g dash is the acceleration due to gravity what is given. So I will substitute and we will get the value of time. So one thing, in order to solve the projectile motions, we have to know about what is the horizontal range and what will be the maximum height. We know the formulas. So here maximum height h is equal to formula u square sin square theta by 2g, and range formula u square sin 2 theta by g. Maximum height formula u square sin square theta by 2g, and range is equal to u square sin 2 theta by g. Now we know that the body is projected with some velocity v. So here I will change it is v. It is v. Now see h formula, h is equal to what is given? V square sin square theta by 2g is equal to half g dash. What is g dash? G upon 0.81. G upon 0.81 into t square. Now we can write these two and these two get cancelled. Then I will write here t square can be written as cross multiply 0.81 v square sin square theta by g square. T square is equal to 0.81 v square sin square theta by t square. Now we can find t value easily. T is equal to 0.9 v sin theta by g. 0.9 v sin theta by g. I will substitute t value in 1. I will got range. I will got this one. I will add both and compare with nd. So I will get the equation. So I will write here. I will erase and I will write. See here, range is equal to v cos theta into t. T already we calculated. I substitute here. Range is equal to v cos theta. T value 0.9 v sin theta by g. So we will write range is equal to is 0.9 v and v square sin theta and cos theta by g. Sin theta cos theta by g. So range I will write, range can be written as 0.9 v square. I will write sin theta cos theta as 2 sin theta cos theta. 2 sin theta cos theta by 2g. So we know 2 sin theta cos theta is sin 2 theta. 0.9 v square sin 2 theta by 2 into g. Just see this expression, v square sin 2 theta by g. V square sin 2 theta by g is nothing but the range. So initially when the body is projected with v under gravity, what is the range is given? The range is given as d. So I will write here range can be written as here I will write 0.9 by 2 into d. 0.9 by 2 into d. So I got the value of range. Range how much I got? 0.9 by 2 into d. So I will add these two and compare with nd so that I can calculate the value of n. So now we will do. We got range is equal to 0.9 by 2 into d. So here d dash is given as, d dash is nothing but, d dash can be written as this d by 2 plus 0.9 by 2 into d, which is given as nd, nd. So he is asking find the value of n. N we can calculate from this expression. We will write d by 2 common. So we can write 1 plus 0.9. 1 plus 0.9 means 1.9 given as nd. So here d get cancel. So n is equal to 1.9 by 2. N is equal to 1.9 by 2, which can be written as 0.95. 0.95. So answer n is equal to 0.95, and it is advanced 2022 question, again based on the small concept projectile motion, but here what is given is gravity is changed, so we can apply like this. I hope you understood. Thank you.